All right, so I'm going to pull up the handy dandy spreadsheet. We're just going to do this. Pull up the handy dandy spreadsheet, and I want you to type out. You can do it on your calculator or you can do it on the spreadsheet, because we're going to do several things with it, and I'm just going to explain 9.2 as we go. All right, X 35.7. 37.2, 34.1, 38.9, 32, 41.3, 32.5, 37.1, 37.3. And yeah, y'all supposed to be writing these down, putting them in your calculator, or putting them in your Excel spreadsheet. 38.8, 38.2, 39.6, 32.2, 40.9, 37, and 36. Let me make it go down just a little bit.
Is there anything past 36?
Nope, it should be 16. Now go ahead and put them in order. I don't care what you use, either by hand, use your calculator, or use Excel spreadsheet. I want you to go ahead and find the mean, median, mode, range, mid-range, all that good stuff. And then we're going to talk about finding the t-value. I'm going to go ahead and put them in order. Everybody's finished writing them down. Has everybody finished writing them down? Okay. I'll wait. Yeah, I'm kind of giving up on movies right now because all the movies right now pretty much suck.
Did you see Us?
I tried to watch Us, like I said, about 20, 30 minutes, I just turned it off. I couldn't tell what the heck was going on.
You really have a storyline to it.
Yeah, and plus you couldn't see anything.
It gets better towards the end.
Well, it lost me.
It's a confusing movie, though.
If it was anything like the first 20, 30 minutes that I watched, I'm glad I didn't watch the rest of it.
I guess you just need to drink you a glow stick and all the movie will be better.
What?
So I guess you just need to drink you a glow stick and the movie will be better.
Yeah.
The 20 to 30 minutes that you watched, how much of it could you actually see?
I couldn't see much. I know the dadgum house was dark, and the outside of the house was dark. I mean,
Was it inside dark?
yeah. I mean, you couldn't see nothing.
And I believe in like lights.
It was almost like the movie about the lights, out with the lights, or lights out. You couldn't see nothing. I mean, I understand the whole concept of it being dark. I understand that, but you're shooting a movie, okay? If you're shooting a movie, you can't see nothing. Maybe I'm just crazy.
Speaking of scary movies, do you watch Insidious?
And I've tried to download Pet Cemetery, and I can't download it. I think it's going to be forever before I download it.
Have you seen Insidious?
Yeah,
That was a good one.
I like Insidious. It's not my favorite. I like the Conjuring movies better than Insidious, but
Doesn't it have like a sequel?
What's like the absolute like scariest movies?
I tell you, Annabelle's pretty scary. But Mama
Oh yeah.
Mama is scary.
That one was freaky. I remember I was
Is it like jump scares? Is it like
Yeah, jump scares and just.
Have you seen Eagle?
There's one about a baby that was born without a twin. I can't remember. I have to ask my son which is the name of it, but it's the name of a child. I can't not Ruby, but it's the name of a child. I have to ask my son. He remembers it because he was watching it with me and he was like 10 or 11, and he dropped it. He was drinking a drink or whatever. Might have been bourbon and Coke. I don't know what it was. But anyway, he poured it all over himself because it was so scary. Now I got to remember that movie. He remembers it. He remembers. I asked him today. I said, "What was that movie you got scared?" He'd tell me the name of it, but it was a female girl's name, but I can't remember. And she was the twin, and the other twin died at birth.
I know what you're talking about. But
and boy, it scared the crap out of him. He wouldn't watch Mama or Mother or whatever. That movie was scary.
Have you seen Evil Dead?
Huh?
Have you seen Evil Dead?
What's that about? Is it zombies? I don't watch zombies.
No, it's like they're in a cabin or something and like it's possessed and like something like that. I don't quite remember, but it's it's supposed to be like a classic horror movie.
I'll have to look that one up.
They remade it as well in 2012.
I'll have to look that one up. Okay. Now, once you get the mean, median, mode. Is everybody finished talking? Because I'm talking now. I said mean, median, mode twice. Once you get the mean, median, and mode, you can put it into your t value. Now, what is the t value? The t value, where'd my whiteboard go? The t value is basically used when you have more than you need with a z value. Now, this is where things get kind of hairy, okay? T-values are used with bigger numbers, all right? Instead of your z-value, instead of your z-score, your t-value is used. And you can think, how many of y'all have heard of Guinness beer?
Yeah.
Well, that's where the t-value comes from. There was a guy named Gossett, and he was like the quality assurance manager for Guinness a long, long time ago. And he was trying to figure out why he would pull group samples. Now, what is group samples? Well, one day he'll pull 10 containers of beer. And then a week later, he'd pull another 10 containers of beer. And he'd do that for several months. And he couldn't get the z-scores to work. The z-scores wouldn't work. It would not give him the same numbers that he needed. Okay? So he, along with another mathematician, I can't remember his name, came up with a t-table, because Gossett was pulling groups instead of what? Individuals. And remember, since 8.1 and 8.2, we're dealing with groups. Okay? So that's where the t-value comes in. Go ahead and write this down because you're going to need it. T is equal to x minus x bar over S divided by the square root of n. Now this looks familiar, doesn't it? This looks like your z value in 8.1 and 8.2. Remember that when I told you to write down? Basically, that is the difference. So if you plug in your values, you can actually find the t value. And the z value and just draw this out because this will make a little bit of a difference. 0, 1, 2, 3. The z values are usually good with small numbers and individuals where you have 3 standard deviations to the left, 3 standard deviations to the right. That's your z values. But the t values pretty much go like this. When you're talking about bigger numbers, the spread is further with a t value. So when you're talking about bigger numbers, when you're talking about a bigger spread, that's why we go with the t-values. Now, do you have to know it like, will the book assume that you know it? No, they'll say, find the t-value. Okay, so I'm looking for a good example. No, I'm not going to do that one. So if you want to find, I'll go ahead and give you an example here, and we'll come back to these numbers here in just a second. Let me go to the whiteboard. Like I said, this is not my favorite section unit. Find the t-value area. Find, this is the kind of question you'll see. Find the t-value area. Area, remember, area under the curve could be a percent, 4 digits, 4 decimal points. Probability, all those are the same number for area, just like in chapter 7. Equal area to the right, find the value area to the right. That equals 0.1000, 10%, at 15 degrees of freedom. Now, those of you that have a book, you need to go back to the tables. And I'm just showing you, if you have a book and you don't have a calculator, which most of you do have a calculator. If you look in the book, the T-table, the degrees of freedom matters. You've got to have the degrees of freedom. And when you see the degrees of freedom in a question, you automatically know that's not Z, it's what? T. So write that down. Degrees of freedom means T. So the first thing you want to do is draw what? Draw a picture. For those people that didn't invent the T-table. Okay, 10%. Where is 10%? Well, remember, by the empirical rule, this is 13.5% right here, and this is 2.5. So just by the empirical rule with a z-score, even though it's going to be different, we're going to say 10% maybe is, I'll do it in blue, 0.1000. And I'm going to put it right about here, and I'm going to shade that area right there. 0.1000. Now, why did I pick the right-hand side?
Because it's to the right.
It says to the what? To the right. So make sure you make that note. So now we got to find alpha, okay? Because that t-value in that formula, in that formula is t sub alpha over 2. So you have to find t sub alpha over 2. So if alpha is our 0.10, then that means we've got to divide 0.10 by what?
2.
By 2. And then we've got to look up that number. Okay? So when you look it up, and go ahead and I'll just tell you on your calculator, let's go ahead and go to your calculator, because I'm just going to do it on the calculator. Pull up your calculator, and you want to go to, I think, stats, but it's called, to find the, if you're given the area and you, hold on a minute, I'm trying to do 2 things at one time, and I just can't do it. Hold on. Okay, on a z-table, when you're given the area, you use inverse norm, right? So what do you use with the t-value? You use inverse t. So look for inverse t. It should be second vars. There it is. Inverse t. Area. Now, be careful here, because what's the calculator, now think about it, when you do inverse norm and when you do inverse t, what is the calculator reading? On the left-hand side or the right-hand side? The left-hand side. Write that down. on inverse T and inverse norm, the calculator is reading the left-hand side. So you have to remember that. So in this case, you're not going to type in 0.1000. What are you going to type in for the area here? 0.9000. 0.9000. I hate 0.9000. I have to use the mouse. I can't use the keyboard. That would make sense. Okay, degrees of freedom is what? 15. And paste and enter. And there is your T value. It's just like a Z value. It's just a different scale because of what it's used for. So 1.341, write that down.
Well, I have a question.
You're going to use that later. Yes, sir.
So did you change your, like, for my area I put 1.9, is it not 0 and 1 after that? Because it gave me a different number.
0.9000.
Yeah, but it gave me 1.28.
And you hit inverse T?
I would not use the inverse norm. What else did you just say?
What did you find inverse?
We're using inverse T.
What did you find that? Because I didn't hear you say that.
What did I find? What?
Inverse T.
Oh, second norm. I'm sorry. Second bars. I might have said norm. I'm sorry.
I don't see it in that.
Now, if you don't have it, then that means you need to either get a new calculator or you need to download the TI-84 onto your phone. Somebody came to me after class the other day and asked me about that. We couldn't find it.
It's another TI-83.
I don't think so. I think that's who asked me Friday or Thursday. So that's when you go to Wabbit EMU and you need to pull it on your phone for, I don't know about iPhone, but the Droid is free download. So
Yeah, I have T PDF and T CDF.
I don't think it's on the TI-83 because somebody came to me Friday or Thursday and asked me the same thing. Sorry. Hold on a second. I'd like to. Okay, so now we've got our T value is equal to 1.341. And you can also go to you can do this on your own, go to the table, and you want to go under 0.100 or 0.9, I can't remember what they have in the table, and then go to 15 degrees of freedom, and you should get 1.3 whatever. Okay? Now, let's go back to the handy-dandy Excel spreadsheet. Just not hitting on all cylinders today. There. Construct a 95% confidence interval. I'll write this on the board, just hold on. Construct a 95% confidence interval for the mean MPG. These are miles. For those of you that don't know, this is miles per gallon on a 2002 Ford Focus. Okay? There's 16 different miles per gallon. Okay? And you need to put them in order and I told you to do the mean and everything.
I thought that was mile per gallon for your truck.
Not my truck, mine gets about 22. All right. So first of all, 95% means that alpha is equal to point what? 0.05. Therefore, alpha over 2 is equal to 0.0250. So what are you going to find? You're going to find your t-value. Find your t-value for 0.0250. .0250. I just showed you how to find the t-value. So let's pull up the handy dandy calculator. Now what's degrees of freedom? Well, degrees of freedom will be 16 minus 1, which is what? 15. That's just a coincidence that other problem had 15. But second entry, well, turn the dang thing on, Hubert. Second entry, okay, I can't see. You ever just have one of those days where just nothing worked right?
Usually my Monday through Friday.
What?
Usually my Monday through Friday.
No, it's Monday and Tuesday for me. Okay, so I'm going to back up here, and instead of typing in 0.9, I'm going to type in 0.0250. 0250. Enter. I get 2.13. Now, again, use the absolute value, just like the z-score. So 2.131, write that down. T is equal to 2.131. And now we're going to plug and chug. And let's go over here. 36.8 plus or minus 2.131, 2.92 over square root of 16. Now, what does the question ask for? Confidence what? Interval. What's a confidence interval? That's where you have, in this case, the mean is going to be in the middle. And you're going to have what? A number here and a what? A number here. This is the lower bound. This is the what? Upper bound. So that's why you got the positive and negative there. Because this is the what? What is that? Okay. Look at your original. What did I tell you to find? When I wrote down 16 miles per gallon, what did I tell you to find?
The mean.
Okay, so what is 36.8?
The mean.
The mean. Thank you. I actually heard that. That wasn't mumbled. So mean plus or minus what? Well, you have to do the math. Now, I think all y'all can do the square root of 16 in your head. Please do not type that in the calculator, because if you do, I'm tempted to throw you out of the class. 36.8 plus or minus 2.131, 2.92 over 4. Now, somebody give me 2.92 over 4, please. It's going to be around 0.75, 0.74, what is it? 36.8 plus or minus 2.131 times what?
0.73.
0.73. Now somebody multiply 0.73 times 2.131.
1.55.
1.55?
6.
Now what is 1.55? Somebody tell me what that is. If you're adding and subtracting it to the mean.
Standard deviation.
Huh?
That's your standard deviation.
No, but it's used like the standard deviation. Starts with an M. O. E.
Margin of error.
Margin of error, write that down. That's your margin of error. So somebody take 36 plus, or 36.8 plus 1.55. Tell me what you get. Okay, it'd be 38.25. What is it? Come on, it don't take that long. What?
38.35.
So that's where? 38.85? Okay, that's your upper bound. So what are you going to do to find your lower bound?
Subtract.
It's a miracle. 36.8 minus 1.55.
35.25.
35.25. Round accordingly. This is your what? 95% confidence interval. So I can tell you, anybody here to drive a Ford Focus 2002? I can tell you that I'm 95% confident with the data given that if you have a 2002 Ford Focus, it's going to get between 35 and 38 miles per gallon. Off the data that I was what? Given. Not the data that I pulled out, the data that I was given. Make sure you know how to do this. Okay, this is a test question. Now, let's go to our handy dandy calculator. Let's see if I can do this because I'm not used to doing it. Let's see if I can do it. Go to stat. Yes, sir.
You have all your lessons on YouTube, right?
Yeah. Yeah, I have them there. Sometimes if I get too preachy, I don't put them on there, but usually I put them on there. All right, go to stat. Go to stat. Go to calculate. And no, test. Sorry. And look at there. Should be down here. T interval. Look at there. Ain't that amazing? Input. I think it's going to be data.
What's the difference?
L1. Frequency 1. Calculate 0.95. So we got all that. So all we got to do is hit calculate. Invalid dimension. What do you mean?
I got mine in it. You probably didn't put your numbers.
Let me check it again. Stat. Oh, I hadn't put the numbers in. I've got it on the Excel spreadsheet. Okay, go ahead and check it on yours. Okay, go to stat, test, T interval, and go through and hit. You shouldn't have to hit much because L1 is usually default, and put 0.95, and then hit enter. Somebody tell me what you get.
Which one?
35.246.
Good.
354.
And 38 point what?
354.
354. So you can do it on your handy dandy calculator.
Why does it give the option of data and stats?
I guess, I don't know. I really don't know. This is my weakest area in this book, so I really don't know. I'll have to look it up. We can look it up. You can Google it. Google it right quick. All right. So if you're right here, those of you right there, test. What number is it? 0? 8. Thank you. T interval. And then here you type in data, and list would be L1. Now if you punched in another one in L2, you would do L2. And then frequency is usually 1 and 0.95. The only thing really you're going to change is 0.95, because I doubt very seriously, well, you could. I guess you could leave the data in L1 and go do another question in L2 and then change that to L2. You could do that. But usually the 0.95 is the only thing you're going to change. Now, the last thing is very simple. It's just like in the first 9.1. And that is, what if you wanted to go out and survey a number of 2002 Ford Focuses out there in Anderson County? How many should you survey or whatever. Okay? So let's go to our handy dandy formula for N. And it's the same as before. N is equal to Z value times the standard deviation over, what's the margin of error squared. Okay, the Z value does not change here. How large of a group survey in order for the estimated miles per gallon to be within 0.5 miles per gallon. Now, highlight that 0.5 because within, whenever you see the word within, that's your margin of error. So you might want to write that down. With a 95% confidence level. So in 9.1 and 9.2, you will be asked to find the group size that you need to survey, that you need to question, that you need to pull as an example. And in 9.1 and 9.2, you're going to use the same formula. Okay? That doesn't change. So we got to find our Z-score at 95%. You know how to do that. Pull out your index card. It's 1.9 what? Look on the index card. What is it? 1.96 times my standard deviation is 2.92 over 0.5. And you should get 131.02. So that means you're going to survey 132 people that own a 2002, or you're going to pull 132 cars. Now that's if you pull your own data. Now, the 16 that we did, the 16 numbers that we did, somebody had already went through and what? Done the hard work and got you 16 good readings. All right? That's the difference between inferential and regular statistics. Inferential, you're using somebody else's what? Data. They've already done all the work. Okay, now, what should you be working on? 9.1 and what? 9.2. 9.1, 9.2. Right now, your Unit 4 test will cover 9.1 and 9.2. So make sure you get that work done in anything that we cover in Chapter 10. Question, gripe, complaint. All right, y'all get out of here and have a good day. See y'all Thursday. And I do have a PM recording also on y'all's page. So you can look at this one and you can look at the PM because I went over this Thursday of last week with the PM class.